here we go. All right, so you did a ton of law of cosines, law of sine stuff in geometry back when you were a tree. Okay, so not going to go hardcore into it. This first part's going to be kind of quick, but it's all written out there for you. Okay, so I just set up a regular old triangle. Okay, and I just happened to adjust that regular old triangle to be along the x-axis just for happenstance. Okay, all right. So if I got this triangle, so if I lock in point A at the origin, and I lock in point C at the point B, comma 0, because side AC is opposite angle B, so that's B, or side B. Okay. So this side down here, or I should say more importantly, this coordinates right here is going to be B, comma 0. Okay? All right? Then I just need to find the coordinates of point B. Well, if I drop the height here and call it y instead of h, because I need the y component to point B. Okay? So then the sine of angle A is going to be y over c. Okay? Which means then that y is going to be equal to c times the sine of A, which is that y component to point B. I could also say from angle A that the cosine of angle A is x over c, and I just lock this x in right there. Okay? I just say x is the distance right there. That's x. Okay? Part of that height triangle, if you will. And then x is going to be equal to c times the cosine of A, which that gives me the x component of that point. Okay. Now, what I can do is I can say, well, the distance from point B to point C, I can use the distance formula. Distance formula, subtract the x's, square it, subtract the y's, square it, add them together, take the square root. Okay? So I'm going to find the length of side BC. So if I find the length of side BC, which is the same as side A of my triangle, I would get this. X part of B minus x part of C, quantity squared, plus y part of B minus y part of C. Okay. Being that I have a radical, I can square both sides here, so I could get rid of that radical by squaring. Okay. So I get a squared equals that whole inside of that radical. Okay. Then I could remember back to my algebra days, and if I had m minus n and I squared it, that's going to be m minus n times m minus n, which is going to be m squared minus 2mn plus n squared. Right? Okay? So this first one here, that one is going to be, I'm going to square the first term, so c squared cosine squared of A, minus twice the product of those two, so minus 2bc cosine of A, plus b squared. So that became this right there, after I multiplied it out. because I'm subtracting 0, that just could go away. So this part right here could just go away. And then I just really am squaring c and squaring sine. Okay? Now, I'm going to take this term right there and this term right there. Because they both have a c squared in them, I can pull that c squared out of those two terms, and I'd be left with cosine squared of a plus sine squared of a in them. And what's that equal to? 1. That's the hammer. Cosine squared plus sine squared. So this part right here is 1. Which leaves me then with something called the law of cosines. And the law of cosines is a squared is equal to b squared plus c squared minus 2bc cosine of a.
I have a question.
I have an answer.
When you hold the c squared out, is that where I guess that c squared came from?
Yep.
That's why it's in front, but it's not attached to the hammer because you had to.
Well, it's attached to the hammer, yes, but the hammer makes it 1,
Right.
so it's c squared times 1.
Okay.
Yep. Okay. The other two law of cosines are there. Now, back in my day, I didn't memorize the law of cosines, the 3 parts to the law of cosines. I memorized the pattern. And the pattern was, you take 1, okay, so I'd have this, that letter had better be that letter. Okay, so the letters are the same on the bookends. Okay, and then these 2 letters are here. And it's always plus minus the 3 terms. Okay? Now, when we're dealing with law of sines, law of cosines, we have a couple of rules that we need to follow. Okay? First rule that we need to follow is when you're dealing with law of cosines, you go big to small. So when you're dealing with the law of cosines, you find the biggest angle, biggest side first. Okay? Then next, and so on and so forth. We work big to small. Law of sines, we work small to big. Okay? Law of sines, we would find the smallest angle, the smallest side first. Then next, middle, then biggest. Okay? We work small to big with law of sines, work big to small, law of cosines. Okay? And we're going to stay consistent with that all throughout. Alright, so it says solve the triangle. So we have angle A, but I don't have angle B or angle C. I don't have side A, but I do know that side B is 15, side C is 30, and angle A is 35 degrees. Okay? Back when we were talking about the ambiguous case of the law of sines, we said, all right, we got to find a complete, actually, well, we were talking about the different kinds. Side, angle, side, 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 angle, side, angle, 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 side, all those. Okay? Okay? This is a side angle side case. Okay? So in a side angle side case, we need to use the law of cosines, okay? And we need to find the biggest side, right? Well, what's the biggest side that I need to find? A. It's the only side that I need to find. So let's find side A. Okay? So if I'm going to find side A, I'm going to use the law of cosines. A squared is equal to B squared plus C squared minus 2BC cosine of A. Substituting in 15 squared plus 30 squared minus 2 times 15 times 30 times the cosine of 35 degrees. Now, here's the cool thing about modern technology. Okay? If you have a calculator that you can see what you're typing in, type it in. Just got to hit equals a couple of times and use parentheses. Okay? Okay? So, if I go to type this in, sure, there it is, 15 squared plus 30 squared minus, open parentheses, 2 times 15 times 30 times the cosine of 35 degrees. That gives me 387.763.
Why do you stick the 2 in the parentheses?
Just because. You don't have to. I do though. You know. It's one of those things that I've always just done it that way. Okay? But is that A? What is that? That's A squared. So how am I going to find A? I'm going to square root that. Okay? So I'm going to take the square root of that answer. By the way, one of the things that you're going to find that you're going to need to know is you're going to need to know how to use that answer key on your calculator. Okay? Or that answer button. On Inspires, it's control of the negative key, or you could just scroll up and get it too. Okay? But that gives me A here is 19.6917. Now, leave that on your calculator. Leave it on there. Because we're going to use that coming up. Don't round it, just leave it. Okay? Alright? So now I have this. Right? Can I use the law of sines now? Yeah, I can use the law of sines now because now I have that complete fraction. Okay? So, the sine of 35 degrees divided by side A. Okay, and I'm just going to write it as side A. If you want to write it as 19.6917, blah, 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 blah. You go, girls or boys, whichever one you are's. Okay, is going to equal which angle am I now going to find? Why B? Because it's the smallest. Okay, law of sines. Now I switch over to finding the smallest angle. So now I'm going to go with sine of angle B divided by 15.
How do you know that B is the smallest
That is a great question. How do I know that angle B is the smaller angle between B and C? Side length is shorter than the other one. Okay. Longer sides produce bigger angles. Shorter sides produce bigger angles. Or excuse me, shorter sides produce smaller angles. Likewise, smaller angles, smaller sides. Okay. So, crisscross applesauce, do a little inverse sign here. That tells me that, whoa, and whoa. That tells me here that angle B, is going to be equal to the inverse sine of 15 times the sine of 35 degrees divided by side A, which I have still sitting on my calculator. Now, here's how I would do that. Okay? I would use that answer key. I do all my work on paper, go to the calculator last. Okay? So I'm going to go to my calculator now, and I'm going to say the inverse sine of 15 times the sine of 35 degrees divided by my answer. Okay? Divided by that 19.6917 number. And that's going to give me, because I'm in radians, that's going to give me that convert times 180 divided by pi is going to give me 25.9074 degrees. Okay? Now, how do I find angle C? Angle C is going to be equal to what? 180 minus 35 minus that angle B, right? So angle C here is going to equal, I get 119.093 degrees. On the calculator, 180 minus 35 minus my answer. Oops, I missed the one. I don't think I can go back up. Tap the brakes. There it is. And there's my three answers. Now, if I wanted to round to 1 decimal place or 2 decimal places, now I would round. Okay? I wouldn't round anywhere before this because we got to use it all the way through. Okay?
What would you want us to round to?
1 or 2. Preferably 2. Okay? I would like you to now try number 2. Alright, so if this is angle L, it's 25 degrees. And then this is angle X, and this is angle A. The reason, you know who came up with this example? That Mr. Roth guy. Lacrosse. Yeah, exactly. Okay? So then side A would be 7, side X would be 11. We're in a side angle side case again. That's law of cosines. Okay? So, again, I didn't memorize the law of cosines. I memorized the pattern. Okay? If you needed to put B over L and C over X and then go with that, that's fine. But side L squared is going to equal side A squared plus side X squared minus 2 times side A times side X times the cosine of angle L. Filling stuff in, A squared is 7 squared plus 11 squared minus 2 times 7 times 11 times the cosine of 25 degrees, which gives me side L squared as 30.4286, which gives me side L as 5.51621. Okay? Now I can use the law of sines, and I'm going to find angle A because it's the smaller of the two angles. So this would be the sine of 25 degrees divided by side L is going to equal the sine of angle A divided by 7. So that's going to give me then angle A here is going to equal the inverse sine of 7 times the sine of 25 degrees divided by side L as that, and that gave me angle A is 32.4319 degrees. Then I need to solve for angle X. Angle X is going to be 180 degrees minus 25 degrees minus angle A in degrees. So that's going to give me angle X here is 122.568 degrees. Yeah, buddy?
I got angle X was 57.4. Yeah. I don't want to do this.
Did you solve for angle X before you solved for angle A?
Shoot, we didn't do the small one.
Got to do the small angle first, because otherwise you get that. Because remember, when you're doing the sines, we can't get an obtuse angle. Okay? Right? So that's why we have to solve small first when we're going sines. Cosine allows us to get an obtuse angle. Sine doesn't. Yes, ma'am?
Can you explain how you get the angle of X again?
180 degrees,
Which is the total triangle.
the sum of the three,
Yeah.
minus 25, which was the angle that was given to me, minus 32.4319. Good?
Why wouldn't you do 180 minus the other two that you already found added together to get X?
Same thing.
Isn't it? Oh, I don't get the same thing, I don't think.
180 minus, because if I add 25 to angle A, that's going to be 57.4319. So 180 minus 57.4319 gets me 122.568.
Oh, I wasn't doing it right. Yep, you're right.
Really, it would give me 122.5681, but I stopped. Okay? All right, so that's side angle side cases. Now, that leaves us with one final case to talk about, and that is the side case. So if I take one of my law of cosines, okay, and now if I have the three sides, that means I have to find an angle next. So, well, the angle part is this part right here. This cosine of A part is what we need to find, basically. So how am I going to get cosine of A by itself? I want to solve this equation for cosine of A. what would you do first? Subtract b squared and c squared. So we'd get a squared minus b squared minus c squared equals negative 2bc cosine of a. Then what would you do? Divide by negative 2bc. So I'd get, now I flippity-floppity my sides just because that's what I do. Okay? So I'd get the cosine of a is equal to a squared minus b squared minus c squared all over negative 2bc. But because I don't like negative signs in my denominator, I don't like negative signs anywhere, but sometimes I got to deal with them, I multiplied both top and bottom here by a negative, so I get that. Okay? These two lines really mean the same thing. Okay? Now, if I'm solving for the angle, though, then angle A is going to be the inverse cosine of that. Okay. And which one would I find first? Biggest, because it's law of cosine. So I find the biggest one first. Okay? Now, I could find the other two following the same pattern. So if I wanted to find angle B, I would switch A and B everywhere in the formula, right? So if I switch A and B everywhere in the formula, then I get the cosine of B is equal to a squared plus c squared minus b squared all over 2ac. If I wanted to find c, I would switch a and c from my original one, and I'd get that. Now, do you need to memorize those? Probably not, because it was quote-unquote simple algebra to solve for cosine. As long as you know what the law of cosines is, you can find that one very easily. Okay? Now, in a side case comes one extra thing that we have to look at before we even do all of this stuff. Okay? All right? So, here is example number 3. It's at the bottom of your page. Okay? I've got side A as 3. I've got side B as 5. And I've got side C as 6. Okay? The check is I have to determine if this truly is a triangle or not. And the way that I do that is I look at the two short sides. The sum of the two short sides in a triangle has to be greater than the third side. Okay? If it's equal, I just get a straight line. Okay? If they're equal. If it's bigger, then I actually get a triangle. If it's shorter, I don't get a triangle. Okay? So it has to be bigger. The sum of the two shorter sides has to be longer than the third side in the triangle. So 3 plus 5 is 8. And is 8 bigger than 6? Yes. So this is a triangle. Okay? All right? Now, knowing that it's a triangle, which angle would you solve for first? I'd solve for angle C first. Why angle C first? Largest side, biggest angle. Okay? second angle. What are you going to use, not which one? Law of sines. So now which one would you solve for next? Angle A I would solve for next. And then lastly, I would solve for angle B. Okay? Now, we're going to do this problem as the warm-up tomorrow. If you do it now or do it tonight, okay, then that's going to make tomorrow go a little quicker. Wink, wink, nudge, nudge. Do it tonight. Okay? All right? Okay? But that's where we're going to start tomorrow. Okay? Thanks for playing along.